I'm Lexie. I am part of the Geospatial Science and Human Security Division at Oak Ridge National Laboratory. I'm here to present the USS Structures Database, which is the first baseline structural inventory with several critical attributions for the US and its territories. This project has been supported by my wonderful team members, including Taylor, Eric, Ben, Matt, and Jessica. The motivations of building this data set is to respond to the need of having accurate, most updated structure information with consistent quality across US in the event of natural disaster response. Such data set is critical for federal and local emergency responders to prepare, respond, and mitigate right after disasters. We kicked off this project around 2017, and by last year, December, in addition to the structures mapped out from high-resolution satellite images, the dataset also has a consistent metadata and scheme across all states. In some cities, whenever data are available, we also incorporated some LiDAR-derived structures. In order to prepare us future maintaining and updating the datasets, we also assigned a unique building identifier, UUID, to track the changes happened at structure level. The datasets can be downloaded via this URL or scan this QR code. As the pilot study, we also provided occupancy types and primary occupancy for 9 priority states. This is the overview of the workflow we developed to build this data set, starting with curating and pre-processing high-resolution satellite images, and then creating in-house labels, capture structures, and those labels are needed in building a convolutional neural network to map out those structures in images. Annotations and the labels were only needed at the earlier stage of this project. At the later stage of the CNN model development, we leveraged the 59,000 labels to create a robust and generalizable structure mapping model, and then really needed additional labels to create such convolutional neural network models to map out structures. Such a convolutional neural network model was trained and deployed on high-performance computing clusters to process terabytes of high-resolution satellite images. And several steps of post-processing and verification and validation process were followed to produce the base structure footprints. The verification and validation process were performed both automatically and manually to ensure the quality. Mapping the base structures in images is just the first critical step. We then worked on populating critical attributions by leveraging several key data sources, including census housing unit data, high-field open data, Lightbox parcel data. We also developed a machine learning modeling approach to fill data gaps where there was no data source is available. This is the current schema where green-colored attributions are included in the current open data sets. That is available through the URL I mentioned before. The yellow ones are the additional attributions that we are currently working on and expecting to have the dataset updates before the summer next year. Here are some examples of rapid disaster response efforts USS Structures has supported. From wildfire, lava flows, hurricanes, this dataset has become a critical component in FEMA's disaster preparedness and response efforts. Our goal is to continue to refine these datasets and provide richer attributions on structures to continue to improve FEMA's ability to respond both quickly and efficiently. We are currently focusing on these tasks With the 9 priority states, we had seen the benefits of having occupancy class and primary occupancy attribution in disaster response. So we are working on populating these 2 attributions for the remaining states. We are also working on stand up a workflow to extract elevation-related information from other geospatial data sources, including LiDAR and ground photos. In particular, LiDAR, the 3-depth data, has the potential to provide elevation information, such as building heights, highest adjacent grade elevation, and lowest adjacent grade elevation. As an example, these are the extracted structure heights derived from 3-depth LiDAR data over New Orleans. Most importantly, we would like to hear users' thoughts and experiences to help us improve these data sets. Those can be other open data sources that we can leverage, or some of the key attributions that we are currently missing in these data sets. However, they are critical in your applications. Thank you for listening. If you have any thoughts, any suggestions, you can reach me at this email address. And again, you can download these data sets from this URL. Thank you.